An open world like that was just the perfect content to focus on our main goal for the release, which was performance. We want the engine to scale to large and rich worlds. We want to preserve graphics quality. And of course, we want to deliver high frame rates that you and your players expect. So let's check it out, starting with rendering. If you all remember, when we released Nanite with UE5, it supported static geometry. Last year, we brought skinning to Nanite. And now, we're working on Nanite foliage. The only way to have a forest that looks as good as this one is to use 3D geometry for all parts of the trees, just like we do for everything else. However, this is a crazy amount of fine geometry, so we had to rethink how trees are created and displayed. To create them, we developed Nanite assemblies. These 28 little parts that you see are all that we use to build all the spruces from the forest. They are instanced thousands of times and used like building blocks to assemble trees in different ways. And as you probably noticed with the wind effect, they even support skeletal animation, which runs on the GPU. Thanks to assembly, we greatly reduce the storage, the runtime memory, and the rendering cost. Then, to display an entire forest, the challenge was to preserve fidelity and performance from any distance. Let's check up close the level of detail we're talking about here. Lots of details. But this triangle representation is not the most efficient when far away, due to the amount of overlapping. And that's why we made an adaptive voxel representation. But in reality, you'll never see those voxels this close, since when we move the camera back, they're barely a pixel. Nanite foliage is almost done. We are moving it to the mainline as we speak, and it will be available for everyone in 5.7.